In this tutorial we're going to convert some Ordnance Survey Mastermap topographic layer data. In the Surveys Test Data Ordnance Survey Mastermap folder you will find an example Mastermap GML data file in a GZ format. LSS can handle this GZ format or the GML format. GZ is simply a zipped up version of the GML data. Also in this folder you will find a feature code conversion file specific to the GML data type, a prototype to use whenever creating surveys from Ordnance Survey Mastermap data, and some Ordnance Survey 50-meter gridded panorama Ascii files. And I'll be using those to demonstrate how we can drape what is almost always 2D Mastermap data onto a 3D terrain. We're going to begin by creating a survey from the example GZ data file. We select New Survey and I'm going to drag and drop the GZ file here, and I'm going to drag and drop the Mastermap prototype survey so that we're using that to get the legend features. Because most of the data we'll be handling will be 2D data, and it also contains coloured in areas to define things such as buildings, roads, woodlands, etc. That can only be done in LSS if the data is held within the terrain model, because it uses the triangles in the terrain model to apply those shaded areas. What we'll do then is allow the terrain to contain 2D data. And when it comes to draping the Mastermap data onto a 3D surface, we will do some conversion of that data to allow us to perform that task. We now select Input, Convert From, Ordnance Survey Mastermap. I'm going to drag and drop the GZ file. The LSS load file will be given the same name as the currently open survey, so we don't need to define that. I'm going to drag and drop the CNV file that I mentioned earlier. There will be no levels in this data set. I know it's all 2D, so it won't make any difference whether we ignore the levels or not. We definitely don't want to ignore the surface code infill, because that's the purpose of converting this into a 2D containing terrain model. And what this will do is, where you have a sparsity of points along a line, this option will allow LSS to create additional points in order to maintain that link. It has read the header information for that Mastermap file and identified which features are contained within. And it's now asking us if there are any of those layers that we wish to exclude. Well, I'm not going to exclude any apart from the default administrative boundaries layer. The conversion is now taking place with the progress bar in the lower right. OK, now allows us to load the created load file. If we move this dialog away, then you'll see the data being built up in the LSS screen. The file is completed, and we continue. The model has completed, and we can now see it being redisplayed. Let's take a look at a small area of this. Query surface will show us the surface features which have been imported. We have building, road, man-made landform, made surface, structures, etc. But you will also notice that every point within this is a 2D point. What we want to do is drape this over a terrain model. But in order for us to do that, we need to convert these points from 2D to have a 0 level. And we do that by Edit Amend Obs Level, setting the datum to 0, by Selection Filter, and making all observations 0. We now save the survey, and if we query the observations, the points, they are now all 0. The next stage will be to create a terrain model onto which we're going to drape this data set. Create a new survey. This time I'm going to drag one of those Esri Ascii grid Mastermap files into the new survey field. I won't be using the same prototype as I did for the Ordnance Survey Mastermap data. I'll be using my standard prototype. And I will now choose Input, Convert From, Esri Ascii grid, and just a single file. That is our 20 by 20 kilometer 50 meter gridded DTM. And if I over display the Mastermap file, if we just draw a section across a representative area, you will see the terrain surface. So let's go back to the Mastermap file, saving this DTM model on the way out. There are two methods for draping one LSS survey onto another. The first of which is to use the Edit Amend Observation Level command, which is available to LSS Vista or higher users. And that's what I'm going to demonstrate first. I've opened up the original 0 level model and I select Edit Amend Observation Level. I select the other model, which is the SX88 model, which is the Esri Ascii grid DTM terrain data, and I'm going to give every point in this survey the interpolated level from that survey. And if I select Selection Filter and choose All Observations, it will highlight all of the observations within this survey. And as soon as I select Finish, it will amend each individual level to match the level in the DTM of the SX88 model. This is a much slower process than the Input Merge Landform option, which is available to elite users or above, and I'll be demonstrating that after we've completed this particular exercise. If we now query observation, you will see that every observation now has a DTM level. and we select Input, Merge from the SX88 DTM file, Landform, add the terrain levels one for one, but we don't want to add the observations from the gridded DTM model into this one. We just want to get the level for each point at that location in the other model. Now when we move the cursor around the screen, you will see that each point has a level. And if we draw a section through a small area, for ZVI and ZTV work, what you will probably want to do is to build up these blocks of building so that they cast a shadow. So in this next section I'll be showing you how we do that. We go to Configure Legend, and I'm going to create a couple of new surface features. I'm going to call this one 9M, which is going to stand for 9 meter high building. I select a colour and a height of 9 meters. I will now create another one called 25M, which will be 25 meter building. And a height of 25. And finally 12M, which will be a 12 meter building. And a height of 12. These three new surfaces will be representative of this area of housing for the 9 meter. 25 meter will be for this multi-story car park, and 12 meters will be for this area building here. You can build up as large a library of surface features as you need, but I always recommend that you would save them into your original prototype, and you can do that by creating them in this survey, saving it, opening up the prototype, doing Input Merge Legend from this survey, and bringing in all of these new surface features. So I go to Edit Surface, replace surface feature by polygon from this surface feature, building fill, to the 9 meter high building. But I won't add where no surface feature currently exists. So we'll only touch now the existing building. And I now do the same for the 25 meter high building, but this time instead of using polygon I'm going to use enclosure. I pick 25 meter building, and fill in each of these enclosed areas. 12 meter, query section, will show me the building heights, and if I were to perform a query line of sight, you would see that these buildings are casting shadows. And if we go into 3D view, you'll see the terrain model and the shape of it, together with those buildings which I have subsequently added to that 3D model.